Okay, class, this is going to be a lesson on exponent rules, and I know you've had this before at some point in your math career, but it's just a little review. So what I'd like you to do right now is pause your video and copy these exponent rules down in your notes. Okay, now that you have the really three rules written down, what I'm going to do is I'm going to take you through three examples of each type, and we'll go from there. So these are all going down in your notebook, and then I will do additional examples from your packet. Okay, so here we go. So multiplying, when you multiply two with the same base, two numbers are two exponents with the same base, you end up adding the exponents. And you know, when you do these by themselves, it doesn't seem that difficult, but what happens is we get the rules mixed up a lot of times. Okay, so when we're just doing multiplying, it seems real easy. When we're just doing power to a power, it seems easy. Dividing is a little bit more difficult, but when we mix all the rules together, you got to keep things straight. So you have to really go back to the very basics of what an exponent means. Okay, so when I say x squared, that's really x times x. And when I say x to the third, that's x 3 times. Okay, multiplied 3 times. So if I expand this out, really this is x times x. This one here is x times x times x. And how many x's do I have altogether? I have 5. If I put that as one big strand of multiplication, that's x to the 5th. Same thing here. If I forgot the rule is to add the 4 and the 3. But if I completely forgot that, I know I can do the negative 7 times 4, that's negative 8, or negative 28. And then x to the 4th is really x expanded out, multiplied by itself 4 times. And then x to the 3rd is really x multiplied 3 times. So I have 4 of them here, I have 3 of them there, so I have 7 altogether. So this is negative 28 x to the 7th. Okay, the last one here, I just have parentheses instead of using a dot notation, and we go from there. So I'm going to do negative 5 times 2, that's just negative 10. I'm going to do y to the 3rd times y squared, that is y to the 5th. Okay, so you do this enough times where you expand it out, you see the pattern is that I can just add the two exponents, because I have 3 y's here, I have 2 y's there, so I have 5 altogether. Now x by itself, there's a 1 there, you just don't write x to the first. 1x and 5 x's make 6 x's, and then the z to the 7th doesn't have anything to multiply by, so I just rewrite that, and that's my final answer. Okay, power to a power. You know, I have this saying, you're going to hear me say this 1,000 times, and you're probably going to be sick of it by the end of it. But when in doubt, expand out. What do I mean by that? When you're not sure what the rule is for, whenever you're working with an exponent, you can always expand it out and go back to the basics of what an exponent is. Now, the rule of a power to power is just to multiply the two exponents. Okay, but let me show you why you end up multiplying. Okay, x to the 4th squared. What does that really mean? It means x to the 4th times itself. So x to the 4th times x to the 4th is x to the... Now, do I multiply those two? No, there's 4 here, there's 4 here. Now I could keep expanding these out if I wanted. So there's 4 there and 4 there, so that is 8 altogether. So of course you're not going to do that every single time, but that's why you just multiply 4 times 2. Because x to the 4th squared is x to the 4th times x to the 4th, which is x to the 8th. Same thing down here. So what does this to the 4th power mean? This is 4x to the 3rd times 4x to the 3rd, 4 times. To the 4th power means multiply whatever's inside of there 4 times. So if you think about this, I have 4 multiplied 4 times, so that's just 4 to the 4th. And then I have x to the 3rd multiplied 4 times, so this x to the 3rd to the 4th power. So 4 to the 4th is 256, and x to the 3rd to the 4th power, so I have a power to a power, it's the same thing up here, I have x to the 12th power. Now I could have multiplied this, I could have expanded this out, or I could just look at back up here, x to the 3rd, I have 3 x's here, 3, 3, 3, so 3 times 4 I think makes sense, because I have 3 x's 4 times. So that's how I get x to the 12th. That's my final answer. Okay, last one here. So if I expand this out, this is negative 2 x to the 4th y squared. I'm just going to put parentheses around it. I'm running out of room. So I can expand it out 3 times. But I also see that it's just everything in here is to the 3rd power, because I'm going to have 3x to the 4th. I'm going to have 3y squareds. So whenever you have a quantity squared, all right, or a multiple terms inside of there squared or cubed, or to whatever power, anything, every single part inside there is to that power. So negative 2 to the 3rd power is negative 8. I have 3x to the 4th. That's going to make x to the 12th. And I have 3 y squareds. 3 y squareds is going to be y to the 6th. And that concludes that. So I just wanted to show you something back here so you understood your notes. Okay, I have a number 7. I have x to the a power, y, and z. If I take all of that to a power, I got to take every single thing inside of there to that power. That's all I'm trying to show there. So every single thing is raised to the b power, or whatever that might be.